let's look at section 3.3. So we continue our topic with quadratics. We just finished solving quadratic equations in section 3.2, and now here in 3.3 we're looking at graphing quadratic functions. So graphing a quadratic function, the graph of a quadratic function is what we call a parabola. And a quadratic function graph, a parabola sort of has a U shape to it, or an upside down U shape. It has a min or a max point to it. With that said, we're going to talk about how to find that min and max point so we can easily sketch its graph. So we're going to talk about the graphing form, or the vertex form, of a quadratic. And the vertex is that min or max point in a parabola. So our graphing form, or what we call our vertex form, some people refer to it as the transformation form of a parabola, is this function f of x equal to a times x minus h squared plus k. So of course we have our x squared term, and in the vertex form we've got a square that we've created with this x squared term, x minus some constant value of h squared, and we've got this constant term added to the x squared term, which is the value of k. Well, h and k tell us the vertex of our parabola. They're the coordinates to your min or max point. And it depends on which way the parabola opens. And that comes from our value of a. So you can see down here, if a is a positive number, so we have a positive x squared term, we're going to have a parabola that opens up. Right? That's what our parabola would look like. And that would mean our vertex, which is this ordered pair right here, h and k, is the min point of that parabola. So the vertex equals the min point, which is the relative extrema, right? The relative min is the change from decrease to increase. That's the turning point in that graph, which we studied before in our previous chapter. But again, that's if a is greater than 0, right? Opens up. Now, if a is negative, so if it's not greater than 0, the only other possibility is negative. It won't be 0, because if it's 0, we don't have a quadratic. We wouldn't have an x squared term. So a is less than 0, our parabola takes on the upside down U-shaped graph. It's a graph at which it changes from increase to decrease, which is turning point here would be the vertex, right, which is the max point of this parabola. So again, the value of a tells us, again, what our graph's going to be doing. Is it open up? Is it open down? All right, and then we get into another characteristic from this quadratic function graph is what we call the line of symmetry, or the axis of symmetry. So the axis, or some books refer to it as the line of symmetry, is the vertical line down the middle of the parabola. Right? If I ask you to create symmetry with this parabola, we'll draw it in here in blue. We would draw a vertical line passing through the vertex. So that line, which is the line x equal to h, is our line of symmetry. So you see it here on both graphs. There's x equal h. So that's the line that splits that parabola into two equal parts. It creates symmetry, right? It's symmetrical to that line. Of course, the vertex, which is your min or max point, leads us to our minimum maximum value, right? Again, if it opens up, we have a min value. If it opens down, we have a max value. And that, of course, is the y coordinate. So as you see, everything revolves around the vertex. All right, so to analyze the graph of parabola, we must find the vertex. Right, so that's our key piece of information. So to sketch the graph, right, we need to find the vertex. That's step 1. Right, we got to find that vertex so we can then graph it. So let's go ahead and talk about this first example. Now, one thing we like about this first example, example A, is this is vertex form. Right? This is our transformation form, our graphing form. So as you see, this is f of x equal to a times x minus h squared plus k. So yeah, we can see a. right? We can see H, we can see K. So with that said, that implies what? We've got our vertex. So again, our vertex, which is our key piece of information, is the ordered pair H and K, which is the ordered pair of 1/5, whatever subtracted from X in your squared term. Now assuming it's in vertex form, right, we've got our square with X. Where subtracted from X the X coordinate, and of course the constant term that's added to that X squared term is the Y coordinate. So there's the vertex. And we know, right, with this parabola, our value of A is -2. It's less than 0. So we know it opens down. So if we're going to graph in this parabola, we could go ahead and do that. So let's go ahead and build a quick sketch of this quadratic. So as we're graphing in this parabola, our vertex is 1/5. So right point 2 up 3 would be the vertex. And let's draw this parabola. I'll put it in blue. All right. So with that said, right 1/4 up 3. So right here next to the x-axis. All right, there's the vertex of 1/5, 3. And we said again, it opened down, right? So we can go ahead and sketch in this parabola. As we do that, there's your graph. So we got a quick graph, right, with this in graphing form or vertex form. So we can see everything we need. Now, as far as analyzing the graph, so let's talk about all the different characteristics that this graph produces. All right, we know from this vertex, since we have the vertex, all right, let's go to our next characteristic. Does it have a minimum or a maximum value? Well, since we have a maximum point, right, the maximum value is 3. Right, there's the largest output we come up with. And that also leads you to, let's talk about the range of this graph. So remember, the range is a list of all your values, your Y values. So we can see this graph, we could shade it in if we wanted. Where does this graph take place on the Y-axis? All the way from -infinity to 3, the bracket on 3. So there's the range of our graph. Now, one thing that will not change is our domain. Our domain is always all real numbers x. That's true with any quadratic function. Other characteristics that we can look at with this graph, we could talk about the increasing and decreasing intervals. So let's go ahead and write that. Every parabola has an increasing interval and it has a decreasing interval, right? Because we have that turning point at the vertex. Have that min or max point. So let's go ahead and write those intervals in. So our increasing interval. So you look on this graph, I'll shade it in red. All right, all the way over to 1/5. So -infinity, all x values less than 1/5. Graph is going up, right? From left to right. And it's decreasing for all x values greater than 1/5. Right side of the vertex. Right, graph's going down, decreasing in value. So you can see your intervals of increase and decrease. What else could we add to it as far as characteristics? Let's go to our axis of symmetry. All right, so our axis of symmetry, which again is your line of symmetry, is that vertical line right down the middle. It's the line x equal to h, which is x equal to 1/5. So remember, this is an equation of a vertical line. So make sure you're writing in the equation of a vertical line. So don't just put 1/5, right? It's x equal to 1/5. We could draw it in, right? There's that vertical line down the middle of this parabola. There's x equal to 1/5. Right, so again, that's the characteristic, but everything comes back to, right, the vertex, the coordinates of that min or max point. So again, you'll notice we need to make sure that's correct, right, as we're looking at our parabolas. So if you want to check it graphically, you could, and we'll look at one a little bit graphically. All right, I want to move on to what happens when we have a quadratic function, all right, that's not in vertex form. All right? And you see down here in examples B and C, this is usually what we see with the graph of a quadratic function. We usually see standard form of ax squared plus bx plus c. So this is in standard form, right? And write that here beneath it. This is equal to, again, f of x equal to a x squared plus bx plus c. With that said, we don't have a, h, and k looking at. We don't have vertex form. Now we could write it in vertex form. All right, we would have to create a square to do that. So we could complete a square to get it in vertex form. Or the easiest thing to do is to use your vertex formula. So if you want, now I'll show you, let's do this one both ways. I'm going to show you one example. All right, I want to show you, we have talked about creating the square. So I'm going to go on down here. I'm going to do this one first. I'm going to rewrite it, and then we'll show you an easier way. We'll show it two different ways. All right, let's rewrite. Let's do that first. Step one. All right, let's rewrite in vertex form. And we can see all the characteristics. So vertex form, again, f of x equal to a times x minus h squared plus k. Now to do that, to rewrite in vertex form, all right, that implies f of x equal to, we've got 2x squared plus 8x plus 7. Now here's the thing. As we do that, we have to factor out this 2. Because we have to make the coefficient of the x squared term 1. So as we do that, as we factor out a 2 from both the x squared and the x term, all right, we end up with x squared plus 4x. So again, we'll factor out the 2 from x terms. All right, then we can identify the value b and create a square. So remember, vertex form is creating a square with x. So here's our value of b. So b is equal to 4. So as we take half of that, we get 2. So we would add in a 2 squared, right, in this. So half of b squared. Now here's the thing. This 2 is distributed with each term. So whatever you add in, you're going to have to take away on the outside. We're working on one side, right? We're working in function form. So we're not going to the other side of the equation like we did earlier in quadratic equation. We solved with completing a square. We had two sides we worked with. So we got to actually subtract a 2 times 2 squared to keep it equal. So what does that imply? So now we're close to where we want to be. So now I've got f of x. Right, again, I've created the square. We can write that down. I had to complete the square here, which I've done in this next step. I've completed the square. So as I do that, I've got f of x equal to 2 times x plus half of b. So x plus 2, right, squared. Plus 7 minus what? Minus 2 times 2 squared, that's minus 2 times 4, that's minus 8. As we simplify that down. So in the end, if you want to write it in vertex form, and we can even rewrite this plus with a minus sign, we always define it with a minus. X minus negative 2 plus negative 1, which is a minus 1. Alright, so we'll put in the minus 1 there as we add up the 7 minus 8. But there it is. There's our vertex form. So now we can look at this quadratic. We see A, we see H, we see K. So that implies our vertex, right, which is going to allow us to graph it. That ordered pair, H and K, equal to negative 2, negative 1. Right, and since A holds a value of 2 is greater than 0, we know it opens up. So as we go graph this parabola, all right, let's go ahead and graph it. All right, we'll put it over here to the side. We'll build our x and y axis. And we'll go plot this point. So left 2, down 1, negative 2, negative 1. And this is going to be the max point, actually the min point, right? Because it opens up. So as we graph in, as we sketch in this parabola, there it is together. So we've got a quick picture of the parabola in front of us. Now, with that said, we could go through and analyze it. So the vertex is negative 2, negative 1. Now, what I want to show you, while we have it, because everything we're getting ready to answer revolves around the coordinates of those 2 points. So let's go ahead and check it real quick. Since we have our TI, right, it allows us to check our graphs real quickly. So let's go to the y equal button, and let's store in 2x squared plus 8x plus 7. As you graph that, you see a picture of that parabola we just graphed. Now, with that said, I want you to confirm the vertex. So go into your calc menu, right? We'll go in here and calculate the min point. Remember the second trace menu, second trace commands 3 and 4, your min and max commands. A review. And if you hit your min command, it'll ask you for that left and right bound. So you'll take your cursor, slide it on the left side of the min point, which would be the decreasing side of this parabola, and then move to the increasing side, and it locks in. You see down there it says the min point after you hit enter a third time, negative 2, negative 1. So it confirms that vertex. All right? And let's go back to it. So we know our graph is accurate. It's sketched in here correctly. So with that said, let's go ahead and finish off the remaining characteristics. So we're going through and analyzing the graph. Now this graph has a minimum value, right? It does not have a maximum value. It goes up forever. But the minimum, the smallest y value, is negative 1, and that leads us to our range. Our graph takes place on the y-axis from negative 1 up to infinity. Right, and we could shade it in here to look at the range. Let's go back to our graph. Right, negative 1 to infinity. And with that said, of course, domain is all real numbers. It's never going to change. Negative infinity to infinity. All right, now as we go to our increase and decrease intervals, which we know every parabola has. All right, we have one of each. We have a decreasing interval. Write that down. Our decreasing interval, right, we're decreasing from the left side of our vertex. We can shade it here in blue. So from negative infinity all the way to negative 2. Graph is decreasing in value, so x less than negative 2. And then, of course, that's the turning point. So to the right of negative 2, the graph is increasing. So we can write in our increasing interval. And that interval is all values greater than negative 2. And then our axis of symmetry. So our axis, or our line of symmetry, it again is that vertical line down the middle of this parabola. We could draw it in. Right, it's just going to be this line right here of x equal to negative 2. X equal to h. Line of symmetry. So there its characteristics. Now I want to look at finding the vertex using the vertex formula. So let's take that same example. Let's do example B here again. So in B again, I got f of x equal to 2x squared plus 8x plus 7. All right, let's find vertex using vertex formula. So the vertex formula, if you look at it, is derived from our quadratic formula. So our x and y coordinates, all right, we can find by looking at the values of a and b. So h is calculated as negative b divided by 2a. And of course the y coordinate is the value of f with an input of h. It's going to equal f of negative b over 2a. So that's the vertex formula. So in this example, if I'm finding the vertex, let's go ahead and get the x coordinate. So h equaling negative b over 2a. Well, what is a and b? we've got our standard form, right? Here's A and here's B. So that's equal to negative 8 divided by 2 times 2. Negative 8 divided by 4, which is negative 2. And then, of course, K, as we find the y coordinate, it's going to be the value of this function f with an input of negative 2. What's f of negative 2? So we take out x, plug in negative 2, and we'll simplify. So as we do that, we get 2 times negative 2 squared, which is 2 times 4, plus 8 times negative 2, which is negative 16, plus 7. So I got 8 minus 16 plus 7. Negative 8 plus 7 is negative 1. There's K. So there's H, right? And here's K. So our vertex is that ordered pair, negative 2, negative 1. And again, with A being value of 2 greater than 0, we knew our parabola opens up, right? So again, if we were graphing the parabola, right, there's the sketch of that parabola, and we go through the characteristics. So again, that's getting the graph of your parabola using the vertex formula a lot easier than rewriting it in vertex form. So it gives you an alternative. It gives you an easy way to analyze parabolas. And let's do the last example in this set. Maybe then we'll look at an applied problem. Let's take example C. I've got f of x equal to negative x squared plus 6x minus 8. All right, let's graph and analyze. Graph and analyze this quadratic. Now again, I'm going to use the vertex formula. All right, so again, make it quick and easy. Now we've gone over the formula, make this easy to work with. Now with that said, let's go ahead and find the vertex. That's step one always, right? Get that vertex. Once you have that vertex, you'll be ready to graph it. All right, so let's find the vertex. All right, so H is equal to negative B divided by 2A. So what is A and B? Those are the two values I need. So A is negative 1, B is 6, C is negative 8. I need A and B. So as we plug that in, I get negative 6 divided by 2 times negative 1. Negative 6 over negative 2, which is 3. There's the value of H. So there's H. All right, now what's K? The y-coordinate vertex. It's going to be the value of function f with an input of H. So it's going to equal f of 3. So let's go ahead and do that. Negative times x squared, so negative times 3 squared, plus 6 times 3 minus 8. So we simplify it as negative 9 plus 18 minus 8, which is 9 minus 8, or 1. So there's the value of K. So our vertex, right, our vertex, again, is that ordered pair, H and K, which is the ordered pair of 3, 1. All right, so there's our vertex. So now let's go ahead and talk about its parabola. Now remember our value of A. A is a negative 1. It's less than 0, so the parabola opens down. So that means the vertex is going to be a max point. So let's go ahead and build a sketch of what we found here. As we graph in the parabola, build our x and y axis. Right 3 units, up 1. Right here is our vertex. And again, that is the max point since it opens down. All right, so there's a quick sketch of our parabola. As we go through the key characteristics, we have a maximum value. Let's go ahead and analyze. That's the y-coordinate, right? Always equal to K. That's the max value. Doesn't have a min value. It goes down forever, but it has a max. And that, of course, leads us to our range. Our range are all y values less than or equal to 1. So negative infinity to 1 with a bracket. Yeah, domain does not change. We'll write down domain, negative infinity to infinity. We know that our increasing interval and decreasing interval revolves around that vertex. Let's go ahead and write in that interval. So we're looking at our graph as we go, and we can go back to our graph here. Let's put it in blue. As we look between -infinity and 3, our graph is increasing. So all x values less than 3. So remember, we never use brackets on increase and decreasing intervals. So keep that in mind. Right? We're looking to the left and right of that vertex. Our decreasing interval, as we look at our graph, that's our turning point there at the vertex. All x values greater than -3 or +3, so 3 to infinity, is the decreasing interval. And then our line of symmetry, or the axis of symmetry, our line of symmetry is the vertical line, x equal to 3. So again, that vertical line right down the middle, right through the vertex, is your line of symmetry. All right? So that's quadratic graphs. Easy to graph once you have the vertex. So find the vertex is going to be our work. Let's take that in mind. Let's go to an example from our book here. All right? As we look at 41 and 42, some exercise out of the textbook. All right, I want to look at an application of quadratic graphs. All right, so taking an example, all right, let's do, all right, how about we do problem number 42. Height of a projectile. It says a stone is thrown directly upward from a height of 30 feet with an initial velocity of 60 feet per second. The height of the stone in feet, t seconds after it's been thrown into the air, is given by this function s of t. All right, so let's write down this function here, this model. It models the path of this projectile as launched into the air. S of t is -16t squared plus 60t plus 30. Determine the time at which the stone reaches max height and find the max height. So keep in mind what this model represents. So S is the height in feet, height of projectile. And it's a function of time, right? As we launch it into the air, different time intervals, it's going to be a different height. And it says t is in seconds. So again, this is our time value, or it's a function of time. So with that said, it's a quadratic model, right? And if you think about, let's draw a visual of this. So we're standing at a height of 30 feet in the air. So let's think about, for example, maybe you had a hill, right, you're standing on. You're standing on this hill that's 30 feet up in the air. All right, as we have this quadratic model, and I'm going to write down the characteristic. A is -16, less than 0. This is a parabola, right? It opens down. So as we would look at this projectile, we throw it up, project it into the air. Right? Due to gravity, it's going to eventually reach a max and start to come back down to the ground. So as you see here, there's a visual. Yeah, we can understand. Here's the ground. There's our projectile path, that upside down U-shaped parabola. And right here is that max point, right? This is the value of t, s of t. Here's the vertex, right? Here's the max point of this parabola. It's where it changes from increase to decrease. So we have to find the vertex. So to answer this question, right, we know again at time t equal to 0, we were 30 feet in the air. T equal 1, it starts to go up, go up, go up, go up until we get to this time value, t. We get to our max height. So if we're going to answer this question, we need to find the x-coordinate of this vertex. So t will be calculated as -b over 2a. So that would be -60 divided by 2 times -16. So again, plugging in our values of a and b. All right, so as we do that, let's go ahead and simplify down. Alright, so what is negative 60 divided by negative 2 times, or 2 times negative 16? That's negative 32. And as we divide that, we would get, what, 1.875. So if you're looking at how many seconds, you're talking about almost 2 seconds. So our time value is going to take, again, reaches, go ahead and answer our question. Reaches max height at 1.875 seconds, to be exact. There's our time value. Reaches max height, almost 2 seconds. So there's the x-coordinate, right? 1.875. Now we got to get the y-coordinate. All right, now we want to find the max height. So what will the max height equal? The max height would equal s of 1.875. So we got to go evaluate our function. Right, that would be our maximum height. We're going to plug in that x-coordinate to get the y-coordinate, get the output. So that's equal to negative 16 times 1.875 squared plus 60 times 1.875 plus 30. Right, and you can go put that in on your TI. Let your calculator do it. So if you want, let's go do it together. Get your TI out. Give you a second to pull that up. Alright, let's go to our home screen and let's type it in. So we got negative 16 times 1.875 squared. Alright, plus 60 times 1.875 plus 30. 86.25 is what I come up with. 86.25, right, would be our output. So 86.25, and this is in feet. So there's our max height. So almost 2 seconds, we reach max height. What is that height? A little over 86 feet. But again, how did we find it? Finding the vertex of this quadratic, right? This projectile took the path of a parabola, parabolic path. So again, everything revolved around that vertex. So that's a good application of using the quadratic function. So I hope that helps you with quadratic graphs. So that's some good examples with this section.